Hello everyone, this is Professor DePaulo. Welcome you back to Site 265, Research in Psychology, fully online. And today we're going to be talking about the within subjects design. So we went through a couple of different designs. We went through between subjects design with two groups, and then we went through between subjects design with three or more groups, which was the ANOVA, the one-way ANOVA that we talked about previously. Now we're going to be talking about within subject design, which is when you use the same participants and they're in multiple categories or multiple levels of your dependent variable. And this is very useful for studying changes in behavior. So you can ask about a past behavior. People may not be very accurate recalling past behavior, and this could lead to something called retrospective bias. You ask them to remember something, something that happened a year ago in the past at some point, and they kind of maybe vaguely recall it, and they're kind of guessing though. They're filling in the missing information, and that can be problematic because we see that if we ask on surveys, a lot of times what's your experience going back, or do you remember something in the past? People don't necessarily give us accurate information. Another way to study changes in behavior is behavioral diary. I like this approach a lot in that you basically record whatever your behavior is. So you have kind of a baseline measure. So what was your behavior like previously? And then you institute some kind of change. And then you notice that, through the behavioral diary that changes are taking place. And at the end of the study or at the end of the diary journaling or whatever you're doing, you see a big difference. And there's actually been many studies on this where people will actually diary or write about, journal about negative emotions. And what they found is if they report about their feelings, their negative emotions, over time, they're going to be less prone to stress, anxiety, and other physical and psychological conditions. Now, if we're doing this kind of study where we're looking at what is your behavior currently, and whether you're asking them surveys or you're asking them to keep a journal, what is your behavior currently and what is your behavior going to be in the future after you do some kind of intervention? And that intervention can be anything. It could be journaling about your emotions. I've done a study on that where I had subjects journal for about a month. I've done a study with meditation that I talk about all the time in this course where I had them train for about 8 weeks. And then I took a measure before the meditation and a measure afterwards. And that's probably the simplest design to really utilize. And that's called the pre-test, post-test design. So you have a baseline measure you take at the beginning, and then you introduce the intervention. In the case of my meditation studies, I took a baseline measure of anxiety and depression at the start, and then I gave them 8 weeks of meditation, or they got a stress management condition, which I talked about before. And then I recorded their stress and anxiety and depression levels afterwards, after the intervention, whatever that intervention they got. And I wanted to look at, is there a difference pre and post? And that's the simplest kind of within subject design, and that's known as the pre-test, post-test design. It's very easy. There's two groups. You have the baseline or the pre-test, and then you have after the intervention that you utilized. You take the measure again, and you hope that there's improvement. That's the goal. So any kind of interventional research or clinical-based research that is pre and post is going to utilize the within subject design. It's the simplest one. And you could use a t-test here, correlated groups t-test before and after. You look for the difference. Now you can have more than two groups with the same subjects. You can have as many groups as you want, but the simplest design is two groups, pre and post. Same subjects are in the pre-test group, and the same subjects then take the post-test at a later time. And that lets you look at potential changes to the treatment. The first measure is called the baseline measure. So that's where you're at before any kind of intervention starts. And that's really important because you need to know where you're at currently before we know the intervention works. And so hopefully there's a change from the baseline to the end result, the post-test. Now, a repeated measure design is a little bit more complex than the simple pre-test, post-test design. The pre-test, post-test design only has two groups, pre-test and post-test. If you just have a general repeated measure design, you could have multiple groups. So let's say I have a pre-test, sort of an intermediate test in the middle of the treatment, and then a post-test. So now I have three groups. That would be considered repeated measures. You have the same subjects, you measure them at the start, halfway point of the study, you can measure them again, and then you can measure them after the study is done. That's three measures, right? Same subjects for 3 time periods. If it was between groups, you'd have different participants, in the different groups, right? But with the repeated measures, it's the same participants in 2 or more groups. If it's 3 or more, it's a little bit more complex design, but it's very easy to do. And you can do 3, you can do 4. You might want to test it like, okay, beginning, middle, end of the study, and then like say a month later, or a month later, and then 6 months later. Sometimes you do those follow-up studies. Those are all repeated measures designs because you have the same people in each of the groups, right? You have the same individuals that get every possible measure of the dependent variable. So what are the advantages of doing within subjects? Well, these are great designs for looking for change. So you have an intervention or you expose them to a particular stimulus and you're looking for a change within the same individuals. That's a perfect design. I utilize these designs all the time. It's very effective for looking for change over time. So you can monitor them. You can ask them, give them Pepsi first, and then, what do you rate the taste of this Pepsi? And then you give them Coke afterwards. You ask them to rate the taste of the Coke. Now, that's probably not an ideal way of doing it because, if you have Pepsi first, maybe that influences how you rate Coke, or if you have Coke first, maybe that influences how you rate Pepsi. I would rather run this as a between groups design, have different people get Pepsi and different people get Coke, but you could easily run the same person getting Pepsi at time 1 and then Coke at time 2. And that would be within subjects. Also, another benefit of within subject design is it has higher statistical power. So it's easier to reject the null hypothesis. So it's easier to show what you want to show. Basically, it's easier to support your own hypothesis if you run within subject design rather than the between subject design. The reason being is there's less variability if you're running within subjects because you're utilizing the same people. If you run between subjects, there's more variability because you have different people in each group. And if you have less variability, then it's going to be easier to see the differences. And that's why the within subjects design or the repeated measures design has more statistical power than the between subjects design, which is an advantage. And another advantage is you can use fewer participants. So use the same people in each group rather than with a between subjects design, you have to use different people in each group. So you have to have more participants overall. And that could be more costly. You got to pay more people to participate or more time consuming. You got to recruit more people. So there are some advantages of using the within subject design. If you're looking at change over time, this is a good design to use, especially if you don't think the conditions will interfere with each other, right? So if you get stimulus 1 first and then stimulus 2 second, and you don't think that those two stimuli will interfere with each other at all, then this is a good study to run, the within subject design. The problem with this design is, let's say you wanted to give everybody the placebo first and the drug second, or the drug first and the placebo second. That could be a problem because now you're giving them a drug and they can stay in their system. And if you then test them later for the placebo, that drug can then interfere with that later testing. So if there's ever a situation where you're going to have a carryover in terms of the intervention, the treatment is going to carry over to a later point in time, you do not want to use the within subject design. then you want to use between subjects design, which basically means that if you're ever running a drug study, all drug studies are between subjects. They're never run as within subjects because of the contamination of getting the drug. It may contaminate your later response to another drug or another dosage or even to the placebo. And this is what I mean by an internal validity problem. That if you have interference, you create a problem with sort of generating the take-home point of your study. You don't really know what your study is assessing. So when you're using a within subject design, repeated measure design, there are a variety of problems. One I just talked about is the kind of carryover effect, and I'll mention that later. You also have attrition or mortality. This does not generally mean that the participant dies. This generally means that you're testing a participant over time, so they have 2 or more testing sessions, right? Because that's what you need for within subjects design, and they don't show up. So I have this problem all the time in my studies. So they're in my study, I give them the pre-test or the baseline measure, and then I want to give them the intervention over a period of weeks, and then I want to give them the post-test later on. So maybe 2 months later they get the post-test. Well, what happens is they all come to take the pre-test, they start coming to the intervention. When I did the meditation studies, they start coming to the meditation sessions. The problem is they stop coming. A lot of people just drop out. And the reason they drop out is because they're busy, or something happened in their personal life, or there's a global pandemic. This is a good reason for attrition or mortality. That things happen, in the world. I mean, people get busy. People have crisis. Things happen. They don't show up, or they forget about it, or they don't think it's worth doing. They don't. It's not enough money for them. They can't justify it. So this is a big problem with the within groups design, is that you have to rely on people to show up multiple times during the study, and it's hard to rely on that. So that's called mortality. It doesn't necessarily mean the person is dying. Hopefully that's not the case. It's just that they stop showing up for a variety of reasons. So once people start showing up, that creates an imbalance in the treatment. So if I have more people in the meditation group stop coming compared to the people in the stress management group, right? So if more people drop out that were given the meditation than the stress management condition in my study, that's a problem. Because now I have unbalanced groups, and this can threaten the study's internal validity, which is the ability to draw cause and effect conclusions. That's internal validity. If there's a systematic reason that participants drop out, then that can lead to a confound. For example, if women dropped out instead of men, that would be a big problem. Because now, how do I draw conclusions? How can I draw conclusions when I had so many more women drop out instead of men in my study? So now the study is confounded by gender. So maybe gender has to do with the reason why they dropped out. So the best case scenario in terms of mortality is that it's random. Like people drop out randomly. That means, you have the same or similar numbers of people drop out from all conditions. So in my study, which was meditation versus stress management, my 2 conditions, I would want a relatively equal number of people dropping out, a relatively equal number of men and women, a relatively equal number of different ethnicities, etc. Anything that I think can maybe change the results of my study, I want it to be, I don't want it to affect my study. So I want the dropout to be random. If it's not random, if there's a reason why certain people are dropping out versus others, now your study is confounded by whatever that reason is, and then you can't draw cause and effect conclusions. So the study lacks internal validity. That's a problem. There's not a lot we can do about dropout. You can beg people to stay in. You can try to motivate them. generally what we do is we call people, we text people, we email them. If you've been in any of my studies, you realize that, whoever's running the study is constantly in contact. That doesn't mean you're going to show up. People drop out. People just, they have free will, right? They don't want to come. They're not going to come. So what we want to do is motivate people to participate. You want to pay them if possible, but not pay them too much, because if you pay them too much, then they're motivated solely by being paid. And that, we don't really want that. That's going to alter the responses. That might alter their behavior. We want them just to be invested in the study and to want to show up, to feel like they're getting something out of it or contributing to science in some way. But you can't convince everybody of that. You can try your best, but it's really up to the person. And if they drop out, they're going to drop out. And we've lost so many people. I remember one semester we started with close to 100 people. By the end of the semester, we were down to 20 or 30. And it was terrible. Why did 70 people drop out? Well, the study was 8 weeks long. Students are at BMCC, so that means they're taking lots of courses, they're working multiple jobs, they have families, they have lots going on in their life, they're stressed, there's a lot of different things, reasons. So you lose a lot of people, and it's hard to do, but there's not much you can do. You can try your best, but if people drop, they drop. Some other internal validity problems include history. So this is when an external event potentially influences the participant's behavior during the study. So a lot of this is a very relevant point recently, because, we've had a lot of external events. You had Superstorm Sandy going back years and years ago, and that really screwed up any kind of research that was done, because people couldn't get, there was no transportation, there were no subways. And the campus was shut down. That's an external event that influenced behavior during the study. You could also have, a natural disaster, like an earthquake or a global health threat or a virus, like coronavirus. So coronavirus had influence on everybody, profound influence on pretty much everybody that you know, and we're all going through, suffering from it, the after effects of it. We all know people that, unfortunately, we probably all know people that had it or have it. Unfortunately, some of us, including myself, know people that have died from it. And that's going to tremendously alter your behavior, or the assessment of behavior. Behavior might change completely after such a seismic event. So that's the problem of history. Some external event really interferes with your study. It interferes with the internal validity, the ability to draw cause and effect conclusions. As I mentioned, in longitudinal studies, so the longer your study goes, the more of a chance you're going to have these events happen in everyday life that's going to influence your study. So my studies generally are 10 weeks long. That's as long as they go. But what if you're running a study that's years long or decades long? You're going to have a lot of events that are going to influence participant behavior, and some of them are going to be negative for you. So history can be a problem, especially if you make the study longer and longer. So I would not advise running these long studies, decades-long studies. I don't think I could do that, but some people are running them, and they contribute a great deal of knowledge because they're amazing studies. People can follow up with their subjects for decades. It's amazing. I personally can't do that. It's, running 10 weeks is hard enough. 10 weeks was like the breaking point for my studies. I can't imagine people running studies for decades or even years. But people do it. Another problem with internal validity is maturation. So these are long-term or short-term physiological changes that occur within the participant, and they can influence your measurement, your dependent variable. So one example of this happening in my personal studies is I used to give a survey at the end of my study, and the survey was really long. It took maybe 45 minutes to complete, and the participants got, you know, they got hungry, they got tired, their mind wandered, right? And that's a problem of maturation. Physiological changes, their attention span. It's a short-term thing, right? But if you have them sit and try to take a survey for 45 minutes, after about 10 or 15 minutes, their mind starts going in all different directions. So that may alter what their responses are, how they're recording. So these are really problems in long-term studies more than the short-term longitudinal studies, repeated measures designs that I run. I mean, I run a study that's 10 weeks or 1 or 2 semesters long. But if you're running a study that's years or decades long, not only do you have to worry about mortality, both physically, people dying, and also about people leaving the study, you have to, worry about their mental state. They may become more mature over time. They may develop dementia if you keep studying older people over time. And that may influence your responses. So you have to keep that in mind, that the longer the study is, the greater the chance. Also, I talked about history, increasing its the ability to affect your study, but also maturation. That people will just change cognitively or physiologically, and that may alter your study. I see it with just people's concentration going after about 15, 20 minutes. They just don't want to take the survey anymore. Another problem of internal validity is the testing effect. This is when a subject becomes familiar with how you're testing them, with the instrument you're giving, the assessment. So if you ask the same questions pre and post, you may have a testing effect. So the person may remember some of these questions. Now, chances are that's not going to happen if you spread it out enough. But let's say you did a study and you gave the baseline at week 1, and then you gave a really brief intervention, and then you recorded the post-test at week 3 or week 2. Your participant may see the survey and say, oh, these are the same questions that I just filled out last week or 2 weeks ago, and that may influence their results, right? So they might be more likely to give the same answers, which is what you don't want, because you want to show a change over time. You want the intervention to produce a behavioral change that's going to be reflected in your survey or in your whatever measure you're taking. And if they're familiar with it and they give the same answers because they kind of remember what they put the first time, and they're going to put the same thing the second time, that's going to kill your study. So the best thing to do here is either use 2 different measurements. So if you're looking for change over time, don't give the same survey. Give something similar, but don't give the same exact survey. Change the wording or change the questions. Make the questions, similar in a way, but not exactly the same. Because if you give exactly the same, it's going to influence their behavior. Well, you hope not, especially if you give it in a short period of time, but it can. Now, if you want to spread it out, like for instance, I spread my surveys out 10 weeks. So you have the pre-test or the baseline at week 1, and then you have the post-test at week 10. Now, if it's the same survey from week 1 to week 10, chances are you're not going to remember anything. Chances are that's not going to happen. You're not going to be too familiar with it because it's 10 weeks apart. But if you're giving it close together in time, then the testing effect is going to play a bigger role. You see the same thing in terms of classroom settings as well. So if I gave a pre-test, like a practice test, let's say I gave you a practice test for the exam. And you're probably already saying, I'm going to get emails now saying, I want the practice test, right? If I gave you the practice test and then the next week I gave you the same exact test, same questions, but it was the real test, then you would say, wow, that's amazing. Like, you would remember these things. And you'd probably do a lot better on the test because you had the practice test. So that increase in score is due to the familiarity you have with the material. In this case, it would be the exact same material, would be evidence of the testing effect. But you may even see this in a less obvious situation. For example, for the final exam, I'm going to give you a study guide. And the study guide is going to be very similar and very directly related to the final exam. I generally don't like to give study guides in online classes because online classes have advantages that non-online classes don't have. It's much easier to take the exam at home than it is to take the exam in the class. So grades are generally inflated now due to all kinds of problems in our society right now. That may not be the case. The first time the grades weren't as good, but if I give you the study guide before the final exam and you prepare with the study guide, I guarantee you it's going to help you when you get the actual exam. And your scores are going to be a lot higher because you've been given a preview of what the material is, and that's due to the testing effect. You're much more familiar with the material, you're going to do better. And one of my favorites is order effects. Now, order effects are the bane of your existence if you're using repeated measures design or the within subjects design. They're the same thing. I interchanged repeated measures design, within subjects design, right? They mean the same thing. So order effects are a big problem in these designs because if you have multiple conditions, then the orders in which you experience those conditions can affect the outcome of the study. So this is basically the order in which you get the different levels of the independent variable. One way to sort of put this is if I was giving you different dosages of a drug. So let's say I gave you a new antidepressant that I was testing, and I'm doing a repeated measures or within groups design. So that means the same participants are taking each condition. And I'm just changing the dosage. So there's 4 different dosages I'm checking. Right? There's 5 milligrams, 10 milligrams, 20 milligrams, those are 3 so far, and then placebo, which is 0 milligrams. Right? So those are from my 4 conditions. And the goal is I'm going to give you one of those 4 conditions first, and then measure your level of depression. And then at a later time, I'm going to give you a second dosage, and then once again, measure your depression. And then keep doing that till you get all 4 treatments, the 5 milligram of the antidepressant, the 10 milligram of the antidepressant, the 20 milligram of the antidepressant, and the placebo. So you're going to get all 4 of those. However, the order in which you get those 4 conditions is going to have a big impact on your levels of depression. For example, let's say you get the 20 milligram antidepressant first. Well, now your depression is probably going to be a lot better, right? You would expect a bigger effect from 20 milligrams. And so then if I give you, 5 milligrams second, it's going to carry over. This is what I was talking about, carry over. The fact that you got 20 at the beginning is going to carry over to the next administration. So no matter what dosage you get, you're carrying over the effect of that drug. And that creates a big problem because now we don't really know, is it the dosage or is it the order in which you receive the dosages that's having the bigger effect here? And chances are it's the order, right? I mean, if you get a high dose of the drug at the beginning, you're probably going to do better on all the 3 subsequent trials than someone who gets a low dose or the placebo at the beginning. So to make up for this order effect, sort of screwing up our study, we can then try to control what order, which participant gets which particular order. So if there's 4 treatments, there's going to be a bunch of different orders in which you can receive those treatments, right? Treatment A, B, C, and D. Due to either a carryover effect or even practice effect, right? You're going to have interference. That's why you need to have the different orders. So different participants have to receive different orders of the independent variable, of the treatment. You can't just give one order to everybody and say, okay, I'm giving 50 milligrams first or 20 milligrams first of the drug, and it seems like all the drugs work, right? Whether they get 20 milligrams, 10, 5, or placebo, they all seem to do better in terms of depression. No, that makes no sense because what if you gave them the placebo first? You're going to get a whole different read of the situation. So the order in which you get the effects, within subject design plays a big role in your outcomes. So we need to balance those orders. And you also have, if you're doing a non-drug study, you're doing some kind of task, the participants are going to get better at that task. So by the fourth time they're doing a task, whatever you're doing, they're familiar with it. So they're going to do better, right? The more practice they have, the more exposure. So whenever you have more than one condition, you need to balance the order. So by now you know that I'm really serious about balancing the order. Now, a couple other things that come out of balancing the order. You control for fatigue effects. So this is people getting tired. If you gave the same order to everybody and people started getting tired halfway through, well, then the intervention, the levels of the independent variable at the end of the study are going to produce poor results, not because they're not effective, but because the person's tired. So order effects, if you balance the order, you will eliminate the fatigue effects. So you eliminate people getting tired. They're going to get tired, but they're going to get tired in different orders, right? So you're not giving the same order to everybody. So some people get tired on one particular level of the variable, and other people get tired on a different level, that same variable, because you're actually mixing up the orders. The carryover effect, which is what I was talking about in terms of drugs. So all drug studies potentially have carryover effects. Whenever you're manipulating anything physiologically, you might have carryover effect. For example, let's say you were testing not drugs, not antidepressants, but let's say you were testing caffeine, and you gave someone a soda, caffeinated soda, and then you had them take a memory task, and then the same person got a cup of coffee, and then they took a memory task, and then they got a glass of water, and they took the memory task, and you wanted to see if caffeine affects memory. Well, in that case, you have to give it in different orders, because if they get the coffee first, that caffeine surge is going to last through the other conditions. It's going to interfere with the conditions that follow it. That's a carryover effect. So any kind of substance, drug, physiological manipulation, don't run it as within groups. Those studies are best run as between subjects or between groups. And then sensitization, this is also the person becomes more familiar with the study, and that may influence their behavior later on. So this is kind of similar to praxis effect. They get better at it, right? They sort of figure out, they guess what the study's about, and they figure it out towards the end of the study, and they start responding differently. So these things, all these, the fatigue effect, carryover effect, sensitization effect, these things will all screw up your within group study unless you balance the orders, or if you can't balance the orders and you still have a problem, run it as between groups, between subjects instead. So here are the solutions to the order effects, or the problems of order. You can randomize the orders of levels. So if I have 4 groups, here are my levels, right? So the first person might get 1, 2, 3, 4 in terms of the treatment. The second person will get 2, 1, 3, 4 in terms of the treatment groups. The third person will get 3, 1, 2, 4. The fourth person will get 4, 1, 2, 3. And then you keep going, right? You would randomly assign each participant to one of these groups. The problem is there's a lot of groups here. There's a lot of different orders. So if you use all possible orders, you're going to have an excess number of groups. So the more groups you have, or the more levels in the independent variable you have, the higher this is going to be. So one way of doing it is give them all possible orders, like I showed you on the previous slide. With 4 treatments, 4 levels of the independent variable, or 4 treatment conditions, you're going to have 4 factorial levels, and 4 factorial groups, I'm sorry, which is equal to 24. So with 4 levels, you're going to have 24 possible orders. And then you would have to randomly assign each person to one of these 24 possible orders. That's a problem. It's a lot of orders. If you have 5, guess what? It's going to be, if you have 5 levels or 5 treatments, it's going to be 120 orders. You don't want to randomly assign each person to one of the 120 different sequences. It's kind of ludicrous, right? There's too much work. But that's how you would do it to counterbalance. So counterbalance is the idea of eliminating the order effect by making sure everybody gets a different sequence of the order, a different order sequence. That's called counterbalancing. And this is one way to do it. This is called complete counterbalancing. You come up with every possible sequence, in this case 24, and then you randomly assign to one of those 24 sequences. Each person gets randomly assigned to one of those sequences. That's a lot of work. You know, I don't necessarily see that as a good thing. Instead, you want to save time, you want to save effort, you want to save your sanity. You can try something called a Latin square design. So Latin square design is the same, it's counterbalancing, but it's not complete counterbalancing. So you're not looking at every possible order, but you're making sure that each condition precedes and follows every other condition. Okay, that means condition 1 always has to either precede condition 2 or follow condition 2. And the same thing with condition 3. It has to precede condition 2 or follow condition 2. Precede condition 1 and follow condition 1. So every position has to have an equal chance, right? And this makes it much easier to counterbalance using a Latin square design. And think of the Latin square design as Sudoku. Here's your Sudoku. You've ever done Sudoku? It's that crossword thing with numbers. I had a book that someone gave to me as a gift at one point. And so that one day I just opened it up, I started doing it. And it's like different levels of difficulty. And you have to have, the numbers 1 through 9 have to be in each row, only once in each row, only once in each column. And then there's different squares, and it has to be only once in each of those mini squares. So if you've ever done Sudoku, you've done Latin square, right? So solving the Sudoku puzzle is solving the Latin square. And that's what we have here. If you look at the 4 sequences, right, in the Latin square, if I have 4 levels, I'm going to have 4 sequences. In this case, I had 4. That's a lot better than having 24. 24 would be needed if I used every possible order, what's called the complete counterbalance. This Latin square reduces it from 24 to 4. If I had 5 levels of the independent variable, or 5 treatments, I would need 120 possible orders if I used every order. But if I did a Latin square with 5 treatments, I'd only have 5 sequences. So as you can see, it's a lot easier dealing with 4 rather than 24 sequences, dealing with 5 rather than 120 sequences. And you solve it like you solve the Sudoku. As you can see here, the condition 1 is in each row once, in each column once. The same for 2, it's in each row once, in each column once. The same for 3, it's in each row once, in each column once. The same for 4, it's in each row once, in each column once. And then every condition precedes every other condition one time. But if you just set it up to have a number in each row once, in each column once, you've solved it. You've solved the Sudoku. And therefore you have the Latin square design. And so if you're running an experiment with many conditions within groups or repeated measures design, this is a very effective strategy for counterbalancing, making sure the order does not influence the outcome. That's what counterbalancing is. You want to make sure that the order in which a person receives the treatments does not affect their outcome. That's counterbalancing. The Latin square design is probably the best, simplest way to counterbalance and very easy to solve, to set up a square like this. I'm not going to have you do it on the exam, but if you had to do it in real life, you could either do it on a piece of paper or you can just go on the internet, and there's probably a Latin square generator on the internet, because basically everything's on the internet. You find it, you type in, it solves it for you. It'll make the Latin square for you. So very easy. You don't even have to know how to do it. You can find it online to do it for you. Now, selecting participants. So we counterbalanced the order. We were concerned with all these threats to internal validity, like maturation, mortality. We're all worried about that. We took care of all that. Now we have to have participants. So do we want people to volunteer? Well, a lot of times we do this. In psychology, we generally have what's called a convenience sample. That means we have people volunteer. However, if you have people volunteer, then your sample of volunteers might be different than the general population. And that creates a problem with external validity. So can you generalize your results to the general population? That's external validity. If you have just a convenience sample or a volunteered sample, you have trouble doing that. So the best way to sort of deal with that is replicate. Replicate your study with different people, different sample. The problem is people don't do that. They just run one study and they say, we found this, and that's it. And there are other people say, well, we kind of did the same study, we didn't get the same effect, and then you get these replication problem that I had mentioned previously in the course, that you can't replicate other people's studies. And that's a problem not just in psychology, that's a problem everywhere. But it's a big problem in psychology. For some reason, we're not replicating studies. It's just, I think because the effects we're measuring are pretty weak. There's a lot of problems within psychological research, and we have a long way to go to make it a lot better, right? We're not like even in the realm of research with regard to, like, say, physics or even biology. If you look at physics and biology, if they do a study, they get high correlations, 0.8, 0.9. In psychology, you would never get 0.8, 0.9 correlation. It's almost impossible. If I saw 0.8 or 0.9 and I was reviewing a paper, I would say something's wrong. We're happy with 0.4. If you get 0.5, it's like a celebration for a correlation. But in the physical sciences, they're getting 0.8s and 0.9s, which is just showing you that they're studying things that are just more easily measurable. In psychology, it's hard to measure things. And we have to work at sort of improving this. There's going to be a lot of, it's a new field, psychology. It's only been around since the late 19th century. It's only 100-something years old. So we have a long way to go, and it's exciting. There's a lot of potential. We just have to really work at getting better in terms of research design and methodology and obviously with replication. So I do a lot of studies that are convenient samples, which leads to volunteerism, volunteer bias, and that's a limitation. I don't select a random sample because that would be really difficult. Even if I try to get a random sample at BMCC, I would need to be on campus every day of the week, morning, noon, and night. It would be very, very difficult. I have to run the study at all hours of the week, and I just don't have enough people to work with that will do this. I can't just put a research assistant there and say, you're going to run the study, 12 hours a day, 7 days a week. That's not going to work. That person's going to leave. They're going to say, forget it. So as a result of that, and I can't be on campus 7 days a week, 12 hours a day. Therefore, we need to use who's available, and that's going to create volunteer bias. And that's a threat to external validity. Also, the research participant pool. We don't have that at CUNY. So research participant pool is a great thing that they have at research universities. So when I was at Rutgers, we had one. And what they do is every student that's in the introductory to psychology class has to be in the participant pool. They have to sign up for it. And they have to do a certain number of hours of research every semester if they're in intro psych. What CUNY calls general psych, right? Psych 100. So if they're in that class, they have to do research a certain number of hours, every single student. And if they don't do it, they get penalized. So at Rutgers, if you were a student in intro psych, you didn't do the amount of research you needed to do, you would get your final grade would be lowered by a whole letter grade. So you go from an A to a B if you didn't do the research that you had to complete with a certain number of hours of research. And then what we did as researchers is we had a bunch of people sign. We put our studies online in the participant pool, and people would just sign up to our studies, and it was wonderful. At BMCC or within CUNY, we don't have this, and as a result, we're more likely just to try to get whoever we can get into our studies. It becomes even more voluntary because you can't just go through a research pool, participant pool, and select people. You basically have to find people and basically beg them to be in your study and probably pay them as well, which I generally do. I generally have to pay something to motivate people. Some people will do it for free, but I generally pay a little bit to motivate people to be in the study. And I hope we could get something like this in the future, but I don't know if that's going to happen. We've been talking about participant pool for years. There's no pool at CUNY. There was one at Rutgers where I was a graduate student, and I was an adjunct at Rutgers. And they have it at all research universities, but not within CUNY. And this is a great thing. As I said before, it reduces the volunteer bias because now you have a whole bunch of different students that are, they have different personalities, different characteristics. It's great. It provides a steady supply of participants for research. Now, maybe if we had all of our faculty participating in research, or conducting research, I should say, at BMCC, this would be great, but we have a lot of faculty that are not really so active in research. And that's fine because they're doing other things, and it's really hard to do a lot of research and teach 4 or 5 classes a semester and do all the administrative work we're asked to do, but I always try to find a student to work with every semester and to run studies with the student, just because I want them to get experience, and I also want to try different things out, and I want to keep an active research program, and it's a lot of work. How this is going to change in the future after coronavirus and things are going to might change temporarily. We'll see. Maybe things have to be moved online more. You might see sort of more online research after the whole mess that has happened. Once we have our participants, we're going to analyze our data. If you have 2 groups, so if you have a pre-test and a post-test, you're going to use a t-test for dependent means, or sometimes it's called a correlated groups t-test. And this tells me if the 2 groups are statistically different. That means are they different due to the intervention? Whatever independent variable you're using, is that causing a difference? Or is the difference due to chance? And that's why you want a t-test for dependent means. It determines, you want to look at the p-value. So what is if the p-value is less than 0.05, that means there's less than a 5% chance that your result is lucky. That means if your result is not lucky, then your result is real. Okay, so you want the p-value to be less than 0.05. And that means you have a statistically significant difference between the 2 groups. If you have more than 2 groups, right, then you have what's called a repeated measures analysis of variance. So this is kind of like the ANOVA we did last time, the one-way ANOVA, when you had more than 2 groups and you had between subjects, you did a one-way ANOVA. If you have within subjects and you have more than 2 groups, you're going to do repeated measures ANOVA. And this is beyond the scope of of this class. It's even beyond the scope of my statistics class, the beginning statistics class, because there's some issues with this, right? I mean, there's some assumptions you have to deal with that are way outside of this class, but it's a more advanced analysis. It tests within subject design with 3 or more conditions. And this is what the t-test looks like. So you have t in lowercase, parentheses, your degrees of freedom, which is a little more complicated of a topic, but it's basically, in the case of within groups design or within subjects design, it's going to be n minus 1. So the number of participants minus 1, because you have the same participants in the 2 groups. So if the degrees of freedom is 98, that means you had 99 participants in your sample. Then your t-score, whatever your t-value is that the computer prints out, SPSS or Excel or R, whatever you're using, SAS. The significance level, the p-value, remember I said that has to be less than 0.05. That's what you want, because that means it's statistically significant. And then if you want, you can put your effect size, which is something called Cohen's d. So if you're doing a pre and post or correlated groups t-test, you'd use Cohen's d here. And the bigger the Cohen's d, the stronger the effect of the independent variable. That's all it is. You want that value to be as big as possible. So that means that whatever you did, your intervention, your manipulation, your independent variable, whatever you did worked. So we want the p-value to be small. We want the d-value to be bigger, closer to 1. I want the p-value closer to 0, the d-value closer to 1, basically. If I did repeated measures, then it would be doing F, because it would be ANOVA, and I'd have between subjects degrees of freedom, which is the number of groups minus 1. So if I have 3 groups, I would have 2 degrees of freedom like I have here. That means I had 3 groups and the same people in each group. The second degrees of freedom is called the within subjects degrees of freedom, and that's the number of total subjects minus the number of groups. Then you have an F value. Obviously, the bigger the F value, same with the T value. The bigger the value, the better it is, the better result. So I want bigger F values, I want bigger T values always. The P value, the significance level, I want that less than 0.05 again, so I want the really small P value. And then eta squared is like the D, Cohen's D in the previous example, except that it's for ANOVA. Eta squared is an effect size for ANOVA, so I want that value to be bigger again. So key here is bigger F value, smaller P value, and a bigger eta squared value. That's basically what you want, and the computer will print this out for you easily. It's not a very difficult analysis. And this is not really a statistics course. I wrote the results for you, so I'm not having you do any stats. If you want to take some basic stats, you can take my basic stats course that I offer every fall, behavioral statistics. So hope you enjoyed the lecture. Hope it wasn't too long-winded. I get a little bit too into this stuff. I find this stuff very interesting. I hope you find it remotely interesting. I think that's the bar that I'm setting here. So I hope you enjoyed it. Hope it makes some sense to you, helps you with the learn the material. I'm available through email, through office hours, etc. And hope you enjoy the rest of the week. And I'll see you next week for another lesson. Bye-bye.